ensure that your microphones are kept on mute. Use the chat box for queries and comments. Confirm that the slides are visible and the resource person is audible. Our technical team is on standby to assist in case of any difficulty. Next to formally commence today's program, I now invite Ms. Lima George, Assistant Professor, Department of Computer Science, to deliver the welcome address.
Good evening, everyone. It is my great pleasure to warmly welcome our distinguished guest, Dr. Lija Jacob, an accomplished academician, researcher, and academic leader with over 22 years of experience in higher education. Dr. Lija Jacob currently serves as Associate Professor and Head of the Department of Statistics and Data Science and Computer Science at Christ Pune Lavasa campus. She has an outstanding research profile with 36 Scopus Index publications, 7 patents, and several books and book chapters. And her research spans across machine learning, artificial intelligence, computer vision, IoT, and technology for social good. She has received multiple prestigious research grants, contributed significantly to academic leadership, accreditation processes, and international conferences, and is highly sought after resource person for expert talks and workshops in India and abroad. We are truly honored to have Dr. Lija Jacob with us today and look forward to an insightful and inspiring session. A very warm welcome to you, Ma. Ma'am, it's over to you.
Thank you. Thank you so much. I hope I'm audible. Am I audible?
Yes, ma'am.
Yeah.
It's audible.
Yes, ma'am. Yeah, thank you for the warm welcome, and thank you, Dr. Neeta, for inviting me as an expert person for the ATAL FDP. Thank you so much. So I'll share my screen, just confirm whether it is visible. Hope it's moving.
Yes.
Yeah. Thank you. So I'm so happy to be one of the expert for this ATAL FTP, and thanks to Shandagiri College for applying and getting for such a wonderful theme. The talk of the day, I would say, and almost all the institutions are actually looking for such FDPs, and also we are all moving towards sustainability, green computing. A lot of things are there. So it was a wonderful title when I saw about the FDP, and today my session would be on digital tools, data analytics, AI, and smart technologies in promoting sustainable solutions. So the area I would like to handle would be something related to data. So that is why I've given it like data science, a bit of introduction about what the smart technologies or how smart technologies is contributing to the sustainable solutions and what can be the digital tools and the data analytics parts where we are when we are trying to do some sustainable solution, what can be the data part, digital tool part, and the analytics part. So I'll be giving an intro followed by a small demo using some of the data set in Excel and Colab where we use Python. Hope I'm audible, just to confirm, because I'm not seeing the screen as such. So just to confirm, it is not getting interrupted. Anyone of the audience also can reply.
It is perfectly visible.
Yeah, thank you so much. Thank you. So I received the information that it is of the participants are from different domains. So I'm not sticking onto a particular domain as such when I tell about the sustainable solutions today. So I'll be taking a theme on water and a theme on air quality while we are doing the demonstration. So sustainable solutions today are increasingly driven by data, intelligence, and digital infrastructure. So when I added these four areas, that is digital tools, data analytics, and artificial intelligence and smart technologies, I was thinking how to connect everything with the sustainable solutions. So we'll be seeing today how data becomes insight, and how insight becomes intelligence, and how intelligence become into the final solution, right? So the use case I would be dealing, for example, when I'm telling him, as I said, I'm not sticking on to a particular area. So I was just thinking about AI-driven air quality and climate risk monitoring. So hopefully most of us would be working with academia, most of us will be doing some research, or there can be students who are trying to do the projects in the sustainable solutions. So just wanted to bring in all the perspectives, how it is, how the technology is supporting such solutions. So here in AI driven air quality and climate risk monitoring, the IoT, Internet of Things, data analytics, and AI. So, what is the focus actually? It is focusing on urban cities, public health, and climate resilience. The second use case, if I would say, is a intelligent water and waste management system, where we are using the sensors, digital dashboards, and decision support system, which is supporting for the sustainable development goals on research, optimization, and circular economy. The next one would be very interesting, that is, which is a vast area, but let me try to consolidate it or shorten it with a specific case, that intelligent healthcare resource management, CKD, the chronic kidney disease use case, where the AI models, clinical sensors, where we use the lab data variables, we might think how it is going to be a sustainable solution. Obviously, yes, when we go for the early detection and prevention, then reduced dialysis dependency and optimized use of water, energy, and medical consumables, and also a sustainable healthcare delivery. So see how the sustainable solutions are contributing to different areas or different domains. The problem statement can be different, but see how it is contributing to different domains of a particular area, like healthcare. Now, when we come to manufacturing, it comes like intelligent manufacturing quality management. So AI-based computer vision to identify maybe the defects in the machines or machinery developed, or the products developed. Now, industrial sensors, real-time dashboards, and predictive analytics. So how is it contributing? Waste reduction, energy efficiency, lower material scrap, sustainable production processes. So I just gave you few use cases in varying in different domains. Example: air, water, healthcare, and the manufacturing sectors. Now, how do we move from a particular problem statement to sustainable digital AI solution architecture? So the underlying thing is obviously data, because we are in the period of big data. A lot of data is flowing in different modes, right? So in all the sustainable solutions, data is a foundation of sustainable solutions. So what types of data enables the sustainability in your chosen area? Because as I said, we will be working with different sectors, right? So what are the types of data that enable the sustainability in our area, and the challenges that affect the sustainability? So that should be our thought process when I direct you to this various to the flow of this session. So what types of data enable sustainability in the chosen domain? So I've given nearly four areas. So what is healthcare? So when we dwell depth into data can be, we tell it can be a structured data and unstructured data, semi-structured data, yeah, all in a whole. Let me call it as a big data, which is including image, audio, video, then streaming, etc. A lot of things are there. So just to bring on healthcare, what are the different types of data? One is clinical data, obviously the electronic health records, what we keep, the diagnosis records, what hospital maintains. And then comes the imaging data. Then laboratory data, operational and workflow data. I've given the examples also. And wearable and remote monitoring data, resource utilization, how in the hospitals the resources are being utilized, and the environment and facility data, socio-demographic and lifestyle data when they wanted to predict the possibility of a particular disease in a domain, in a particular section or an area. Now, outcome and follow-up data regarding the recovery time, possibilities of readmissions or the further complications. See how varied the data types are, data is, and what can be the different problem statements or what can be the different sustainable solutions we can provide with these types of data. It is not sticking onto a single problem statement. It will have, you can add n number of problem statements using these different types of data. Now, when I tell about the different types of data, we can see in water and waste management. So the data type can be water flow and leak detection, water quality sensor data, water generation and segregation data, collection route and frequency data, recycling efficiency data. See, the government also is using such data for the policy making. Okay, for even for deciding on the urban cities, for a proper water planning, such data is being used. So that is the importance or the beauty of the data, I would say. Now, coming to agriculture and food system, as we are moving into the precision agriculture, so a lot of agri data is being used. I believe that most of us have worked on the smart agriculture or maybe have applied for many of the projects related to the smart agriculture. So the data types, soil, moisture and nutrient data, weather and climate data, crop health imagery, then irrigation and water usage data, yield and supply data. And especially when we go with the precision agriculture, the systems need or the tools required the such type of data for the development. Now, the another sector, since we are, most of us are in academia, I would like to bring the education and institution sustainability, energy and water usage data, space utilization data, digital learning platform analytics, resource consumption. Apart from the student data, what we always do, students' performance, students, just starting with the performance or prediction of whether the students will pass or fail, etc. See how the problem statement had been moved from the pure academic to the administration level of the education institutions. So this is majorly worked by the education campuses for to promote the green campuses and efficient institutional operation. Please interrupt me when if you have any doubts. Okay, yeah. So just to sample to show about the precision agriculture. Now, before moving into detail, I wanted for us to understand certain terms, that is data, information, knowledge, wisdom, data set, observation, variable, or aggregate. Yes, ma'am. Okay, sorry. So, uh, the data means, I've given the examples also. So data means raw or unprocessed. So I've taken this example for student performance. So just numbers, like I just pointed like marks, but instead of that marks, just think the number like 78, 85, 92. They're just numbers. Okay, they are unprocessed facts. Now, when does that become an information? It becomes the information when we do some calculation, maybe the ranking or the percentage or what say average marks, etc. Now, from the marks calculated or the average marks, we are able to get the insight from that particular information. The students score higher in maths than in science. It can be one knowledge which you are getting after calculation of the marks. And finally, when it comes to wisdom, it is like we should do something on action based on the performance. Okay, if the class is having a lesser percentage in something, some extra classes, or we call it as remedial classes to be given, some peer learning sessions to be arranged for the students. So that is a wisdom we are gaining. Now, the details of all the students, if it is stored in a particular format, especially we teachers maintain that in the format of an Excel, okay, or a CSV file. So that is a data set, a structured collection of data. And each observation, each data entry or a student's record becomes a observation, and it can be the variable or a feature, can be a measured attribute, what we are going to consider for my getting the insight. For example, in this example, we are telling about max, or any subject marks. So that particular subject name would be the attribute. And what is outcome or the target we are going to identify, or it is like we are going to find whether it is a pass or fail. So now connecting all these keywords, that is data, information, knowledge, wisdom, data set, to a broader area: data science, data analytics, descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So the end-to-end process, what we do from the receiving the data to extract the insights from the particular available data. Okay, using some mathematical procedures or statistical procedures or even AI, we call that procedure as data science. While data analytics is analyzing the data to discover the patterns and trends. So let me then again divide that into four. It can be descriptive analytics. It can be like what happened actually, what is actual thing, what is actual, say for example, what is average, which city is having the highest population, or which city is having the highest pollution, okay, or average day by when we calculate a day by day business, where is the average business sales happening more. So all this, that is a descriptive analytics with the data what is actually available. Now, diagnostic analytics will help us to understand why did it happen. So, what can be the reason for a student for the low performance? Is it his sleep cycle? Is it his attendance? Or is it his the involvement into other activities? So, why did it happen? That is the diagnostic analytics. And predictive analytics will be what will happen. Okay, it's like going a bit to the future with the available data what we have. And prescriptive should be what should be done. Okay, recommendations, more recommendations. So even in any firm we take for business, these analytics are happening. That is how they introduce a product. Okay, so what can be the future, or where does this product flourish? All those details is it's not just landing on a business for on a particular day or a time. A lot of analytics is happening, right? Now, when we tell about this data science, somewhere around the term model comes. Okay, so model is a mathematical representation of the pattern. So we are going to create a model in such a way, a mathematical solution in such a way that whatever data we give, it is able to give us some information, some analytics part. Okay, so we'll come to it, and then going with the insight and the decision. So here, uh, when we are not dealing with just 10 or 20 rows and columns or etc. Data means it's huge. If I wanted a product value, or I mean to say, if I have a data set of a business product, it will be huge. Daily transactions. So see, just imagine the number of rows and columns it is having where a business firm is handling. So to get the insights or meaningful pattern, we need some analytics, and we are doing it, and we are getting the insight. And post getting the insight, we are using our intelligence to make the decisions. So insights to actions. So just to brief what terms we saw: data, information, knowledge, wisdom. That is, raw facts are transformed into insight-driven decisions using analytics and AI. Somewhere around, I'll remove AI because it has come to a normal term now. Now, descriptive, dynastic, predictive, prescriptive. Organizations move from understanding the past, understanding the current, and to optimize the future actions. So these are the four terms. Can I get a thumbs up from you if you have, or is the reactions they have said there? So that I can understand whether the participants are following me, or somebody can tell me if shall I proceed.
Yes, ma'am, please.
Yeah, thank you. So, as I said, from the data to actionable insights, it's a stepwise process. So always we go with even if it is a whatever solution. Nowadays, when projects are being asked, when we are applying for some projects, they'll be telling what sustainable goal are we trying to achieve. So the problem statement always aligns with one or two SDG goals as such. So the problem statement or objective, we have to identify a specific challenge that the data addresses, and suppose for example, detecting the defects in manufacturing or predicting the disease risk in healthcare. So it can be anything which I already showed. Now, data collection and features. So it explains what type of data are collected, and we have to identify what can be the variables. Already I told the variable or a feature, and what can be the target variable also. Now, it's not a simple task, because when we say about data, there can be a lot of noise in it also. So for the, I'll come in detail to that. So a step of data pre-processing is required, where we're cleaning the data. Okay. And then come the analysis, where we are getting the trend and the correlations. And then from there, we are moving into the analytics part and the prediction part. And from there, the insights and visualization, where we are able to demonstrate our observations through using certain tools. Okay. And finally, the actionable outcomes and the benefits, how the results solve the original problem and impact the decision. So from a simple data to decision, that is the flow of this framework. Let me connect that to cooking. Okay, so always when we say about data science, we tell that it's almost related to cooking. We are fixing what can be the menu. Okay, we are planning what can be the item today. So that is the research goal or the problem statement. And from there, we are retrieving the data. We get the ingredients. We go to the market and get the ingredients. That is actually data. And the ingredients, do you think it's a pakka one directly to be cooked? No, it needs its own preparation, it needs its own cleaning, it needs its own pre-processing. So all the processing of the washing and cleaning every or removing all the spoiled items and preparing in such a way that the data is prepared and it is too much cleaned, or the item, sorry, in the cooking, the item, the vegetables or whatever you're using, it doesn't have a part of a spoiled item or anything, right? And from there, the data exploration. So now the cook or the chef mixes up things and see how the pattern, okay, and he gets a small samples, from where he is able to know, he will be able to uh, move to the next one, that the cooking the dish, that is actual output actually. So he cooks the meal, and then he will present in, or show that in a present the item or the prepared dish in a proper way, making it attractive, right? So that comes the visualization and interpretation part. So all just think about the data process as a cooking process. Now, for us, what are the ways to collect data? Since our theme is on sustainable solutions, we cannot say always the data is available. Theme and allied
6:27.
data collection method also need to be thought
Ma'am, you are muted. No.
Lisa ma'am, hello.
Hello.
Okay, okay, yeah, yes, ma'am.
Yes, ma'am.
Now
It's
now it's
okay.
fine. Now
Yeah.
it's fine. Yes.
Okay, fine. Thank you, thank you. I Is the PPT shared now?
No, it is
No,
not
ma'am, it
visible
is
right
not
now.
visible yet.
Mm, What happened suddenly? 1 second, ma'am. I don't know suddenly what happened with my PPT. It's going long. 1 second, ma'am. Please excuse. Now is it visible? But I think
Yes, yes,
it's
now
not in
it
the
is
slide
visible
mode now.
now.
Is
Now
it in
it
the
is
slide
Right,
mode?
showing
ma'am.
the slide
Now
presentation.
it is
Yes.
on slide mode, ma'am.
Now it
It's
is correct,
moving.
ma'am.
Yes.
Yeah.
It's correct, no? Thank you. Thank you.
Yes,
Yeah.
ma'am.
Yes.
Yes.
Yes,
Sorry
ma'am.
for the
Yeah.
interruption. So, when we go for the data collection, the primary data collection, I already said, so it has its own pros and cons also. So, for the pros, when we go with, like, it's a specific to our problem statement and it has a high control with what actually we wanted. Okay. And the cons would be time consuming and expensive because each of our problem statement would be different and we may not have a support system for what data to be collected. So it takes time for thinking and then fixing up what the data we need to collect. So usually primary data collection will take comparatively more time. Now coming to the second type, which obviously as researchers sometimes we look into this, that is secondary data collection. So collecting the data from already existing. It can be from the open data portals, or it can be from the organizations, or it can be through some APIs, through some applications, and also the which is already existing through the research papers. So it is faster and cheaper, but the this part we have to check that is whether the data is cleaner and whether already it is pre-processed. So sometimes around we may not get the actual data what it is already collected. We may miss some of the features also while collecting the data. The third part is like web or digital scraping, where we are using certain tools to pull out the data from the websites, or it can be the social media data. So now, here, when we collect the data for the sustainable solutions, we have to make sure that it is legally and ethically following the rules. Okay, and finally, when it comes to the another method is automated or real-time streaming data using the IoT sensors, then city devices or financial market feeds. So it can be of any way. So we discussed about 4 different types of how the data can be collected. Now coming, so we saw how data can be collected and um, the ways to collect the data. Now, what is the smart technology behind the collection of data? So when we go with the real-time monitoring systems or no solutions for the smart solutions, we obviously go for many technical tools. One, and I've just listed a few, that is IoT sensors, IoTs or sensors, where the continuous monitoring is required. So I just wanted you to think about the solution, what you were looking into, and connect that with the details which I'm giving. So then you can connect, or if some of you are struggling with what type of data need to be there, you can, I think you will get some idea on that also. So how to collect the data? It is like through the IoT sensors, or it can be drones. When it comes to the imagery part, it can be drones or some aerial vehicles, and remote sensing satellites. It can be wearable devices, and also it can be the smart meters. So I've put certain areas of usage also. So IoT sensors for almost all the smart monitoring system, we use IoT. Now the forest health monitoring, crop disease detection, mapping the deforested areas, we can use the drones or UAV. And for tracking the deforestation, urban expansion, etc., we can use the satellite images. And now coming for the monitoring the water or energy consumption in communities, personal carbon footprint, etc. We can use the wearable devices, and also the smart monitors, smart meters for optimizing the energy or water consumption. So these are few smart technologies. Another coming is mm, the normal what we almost use, like mobile apps, then automated cameras, AI vision systems, edge computing devices. When there is a challenge of the small, we wanted to collect the data locally, and there is no, sometimes there can be a limited access with internet. So we can use the edge computing devices, or it can be open data integration, where we pull out the data from the already existing parties. So we saw the smart technologies, yeah, that can be used, and what are the digital tools for data collection. So it is almost similar when I said. And just thing about remote sensing. I just wanted to tell about a lot of projects are being done using this GIS. So QGIS is a tool for that help us. QGIS, or the professional version RGIS is a version for it. Or we can use Google Earth Engine for remote sensing data, and even for putting the data onto the maps. Now, for the data processing, so we got the data using certain tools or sensors or whatever we have used. Now, with the data, what are we going to do? We are doing the process, and we are using some analysis tools. There we can start with a simple Excel or Google Sheets, where we can more into the direct or a basic descriptive analytics, and then going on with the, we can use Python or R. Or if we wanted to do something, some backend work on it, we can use the NoSQL or NoSQL databases. And for the visualization and for making decisions, we can use the tools like Power BI or Tableau. And as I said, for the mapping the environmental thing, we can use GIS tools. And for the prediction, okay, so we saw the process of data science. So try to connect with each. So how am I going to collect the data? Is it through a sensor, or is it through is it the image data? So as in the beginning I said about the types of data are different. Okay, so based on the type of data I wanted to solve the problem. Okay, that we have to fix on what type of tool we should use for capturing the data, process the data, and finally, we are trying to make smart solutions, right, using AI. Or we are doing, it's for the future, what we are going to trying to bring out, or we are trying to solve a sustainable problem statement, right? So we can use the AI tools, machine learning algorithms, deep learning algorithms for it. So that can be the digital tools. And I used to work with Python, so TensorFlow or PyTorch can be used, and we have to use algorithms which help us to do the modeling. And finally, coming to the automation and smart system, we can the digital tools used can be smart grids, smart irrigation system, which automates, and a predictive maintenance platform that where we are able to reduce the resource waste in manufacturing. So just to show the flow, what we have seen, data collection tools, digital tools we use for gathering the environmental, industrial and community data. Now for analysis, we can use the tools, digital tools, where we turn the data into actionable insight, and automation or smart system, we apply the insight to drive the real world sustainable solution. So the title which I've given, that digital tools, data analytics, and the AI smart technologies for providing the sustainable solutions. So with this, I would like to move to Excel document, where I'll be showing you the a small data set, and it is a synthetic data set which created by me. And no, I have used GPT also for helping me out with the fields. Okay. Can I get the response from the audience, whether is it going fine, and should I add something else in the explanation? Meanwhile,
Yes,
I'll
ma'am,
share
it's
my Excel
absolutely
sheet.
going fine. No problem at all.
Yeah, thank you. So I'll just share the Excel document. Hope you can see the screen here. Yeah. So this use case I've taken, is it visible for you? I mean to say the size and the content.
Perfect, ma'am. Yes.
Yeah, thank you. So the use case I've taken is identify the wastage or peak usage pattern. Okay, so we have taken the date, okay, date, hour, building, okay, water liters and temperature. So the first thing, obviously, when we get a Excel sheet or a CSV file, what we try to do is we do a descriptive analytics, a basic statistics. So what can be, so based on my problem statement, what can be the descriptive analytics? So my problem statement is water consumption, right? With the data which I've used. So I will be using the total what I'll be trying to analyze what is actually existing in this. Now, total water consumption. So I saw it using just simple commands. I hope all of us are familiar about the basic descriptive measures. I used some, then average hourly usage, then maximum usage, minimum usage, and the variability. So I calculated these are all by default Excel commands. And then I tried to do the trend analysis. How many hours and sum of water liters. Okay. So used a pivot table for it. So I have used a pivot table for it. And with the help of the pivot table, I also was able to understand the day-wise trend. Okay, so when you see the data, see the data spans over the days like 01/2026 to 5th 5/1/2026. Only 5 days ka details are there. Okay, so I have used pivot table to summarize it. Okay, and my total consumption, sum of the water liters over these 5 days. Okay, and you can see the arrows showing the consumption, whether it is low or a higher one. Okay, based on a threshold. Now, after that, as you see in the data, so when we get a data set, please remember, observe the data a lot. Because when we teach data science, we used to tell date with data. Date with data, like how you spend time with your partner, because we have to know each and everything what is defined in the feature. So can somebody type on the chat that how many features are there in this data set? How many features? Or somebody can unmute yourself and tell how many features are there in this data set.
Ma'am, 5.
Yes. So specific, it has given five: date, hour, building, water, liters, temperature. Do we think that every data set will be having only the wanted data, wanted feature? May not. Okay, sometimes when you are collecting data set from, maybe simple example, when we are collecting data from Kaggle, you wanted to know the student performance. There will be n number of columns, but as a a person who really
Hello?
want, yes, hello, any doubts, ma'am?
Ma'am,
No, ma'am,
ma'am,
no doubt.
data set, na, it is a collection of information or raw data, ma'am.
This
Ma'am, am I
it is a
audible?
mixture, I would say. The data set as such, when we say this, these are just numbers, right? Now, when we see, I can transform, I can calculate a value and then put that and add that to the data set. Now, what does it become? It become information. Okay, so
Okay, ma'am.
actually collect a collection of data, but when we start dealing with the data set, what happens? We can even calculate something. Okay, maybe have you heard about when we I want, suppose I am running a business where what happens, I am selling something in region wise. Okay, I had the basic data with me. Now to add more to the, or to get some action or insight, what can I do? I can calculate the daily sales in a particular region, which becomes an information. Hope I hope the
Yes,
doubt
ma'am.
is
Thank
clear.
you, ma'am.
Thank you. Yeah.
Yes, ma'am.
So
Okay,
that,
ma'am.
so this is a very basic data set. I didn't do any manipulations, or I didn't add anything. This is just date, hour, building, water, liters, and temperature. This is just data set, just including some data. But on the go, we can see some additions on the values if I wanted to do it. Okay. Yeah. Thank you. So the second thing what we have done is the trend analysis. Okay, so suppose this is 1,000 rows car data set. Okay, it will be very challenging for us to give a particular or if you are a manager, think yourself as a manager, to consolidate and tell what was the hourly. Is it growing? Is usage of water going high, or is there any connection with the temperature and the usage of water? So all this we need some analysis. So you can use pivot tables for it. Okay, so I've now um, here, if you see the third one, building wise comparison. So nobody will help you to understand what they will just give you the raw data and you find something. Okay, so you find out some and give me some insights. So now let me think about what is a building wise comparison. Which building is using more data? Sorry, more water. Okay, so I've used block A, block B, block C, and then understood. And we can see that which is having the minimum and which is having the maximum usage, which block is having the maximum usage, and representing it using the charts. We saw when we do an exploratory data analysis, we can use the existing data with some charts so that which gives it more impressive and understandable. Now here you can see various colors in this particular hour. See, so what is that? It is just conditional formatting, which gives you an idea about which are the hours, which or how many hours they have used. So we can, this is being ranged from 8 to 17 if I'm not wrong. So which dates, which time, or which what is the temperature when they have used more number of more liters of water. So all this can be used using heat maps. Okay. Now another important thing is correlation analysis. Very so I wanted to connect two features. As you said, there are five features here. Now I'm taking two things, that is the temperature and water consumption. Okay, temperature and water consumption. Now, is there any relationship between the temperature and the consumption of water? So I can use correlation analysis. This just those who have not used it, just try to use CORREL, correlation, okay, of the two columns which actually you wanted to find. So if I see the value is higher. So it ranges from 0 to 1. Okay. The correlation values ranges from 0 to 1. So if it is near to 1 means those things, what are the factors which I've used? Water consumption and temperature. So if it was very closer to 1 or no, we can keep a threshold. Okay. Above 80, I am telling it is highly correlated. So high positive correlation shows that high temperature equal to more water usage. But here we can see the value here as per the data is 0.05, which shows that there is no much correlation, right? Okay. Now, to identify certain pattern, we can even use the sorting and filtering operations. And there can be cases where we have to understand there can be anomalies. I can say it in another term like outliers. Okay, outliers. These outliers can be away from the normal distribution of the data, and sometimes around these outliers can be of different cases. I'll explain with some example. For example, if I have 100 students in my class, I got a normal distribution from maybe 30 to 70, but I could see two students getting more than 90. Okay, it happens, it is an outlier in a specific range. And what happens? This outlier can be of different reasons. In a normal condition, it can be maybe a mistake of the data given, or it can be something. Yeah, we used to tell in academia, we used to tell about advanced learners. These students are so brilliant that they always score near to 100. Okay, that is an outlier. Agreed. That also we need to consider. Now, when it comes to healthcare, this outlier can be a normal away from the our usual vitals, which show a risk. Okay, risk of it can be a disease. Okay, so outliers need to be handled based on the domain which we are taking. So normally as a human brain, we think, is there any mistake in the data which I've entered? Okay, the student got 95, is it a mistake? We usually verify. Now it can be taken another way. When if the data is correct, it can be a student who is an advanced learner. So anomaly detections, and also from the normal flow, if there is any change, we call it as anomaly. So some days the temperature is so peak, okay, or so much down, so that also will be taken in the anomaly when we present it. Now the third one and the final one is the forecasting tool. I will show the forecasting line where we it is showing. Okay, there is a function forecast in Excel which will forecast with the data on the upcoming date. So as I said, we had this blue lines show the data from 0 to 5. That is date 0 to 5th. And the orange lines show what can be the usage. Okay, what can be the usage, and it shows the maximum confidence level and the lower confidence level, and the it can be the possible values. Okay, so it is forecasting till the 9th of Jan 2026. So forecasting, it's a prediction. Okay, so this is how we do simple analysis on Excel. One more data set I would like to show, which is having um, more columns. I'll just share that. It's on air quality. Hope you can see it. So those who've seen, can somebody tell me how many features are there?
8,
Hope you
ma'am.
can see. Yeah,
8.
8. Okay, date, city, PM 2.5, PM 10, NO2,
NO,
CO, AQ1, and
AQ,
health
and
category.
health.
This is a data set I created using ChatGPT, a synthetic data set for the quality index, air quality index. And as we know, mainly the pollutants are calculated. So this PM stands for the particle 2 point with the diameter 2.5, which is researched and identified as one of the most most effective correcting for the feature for the AQI, Air Quality Index. So here we are trying to find in the various cities and which city is more polluted, and what can be the health category of no such cities also. So the date here of different dates are given. So there are nearly 100 rows on this. Okay, so now, as we said, one of the thing when we create or when we receive a data set, okay, when we receive a data set, sorry, this is not synthetic data, this is from Kaggle, okay, AQ data, this AQI data, one data is from Kaggle. So the first thing I was checking is whether there is any blank values or duplicate values. So that is one process of data cleaning. Okay, one process of data cleaning. Why do we need data cleaning? Do you think that data cleaning is required? Any answer? What can be the value? See, for example, our friends circulate surveys, right? Surveys or questionnaires, and normal tendency of a person is if it is not mandatory, we leave it free. Right. Similarly, think about some sustainable solutions. I wanted to receive the data from the IoT sensor or something. There can be some values which is missing. Okay. Now, how to handle the missing data? Okay, how can we handle the missing data? Or there should be some process to observe whether there are many duplicates, there are many null values, etc. So in this data science process, we actually see for it. Why is it required? Should we go for data cleaning? Can anyone answer? A teacher always have a tendency to ask questions, right? Can anyone answer, is data cleaning required?
For getting accurate information,
Certainly, yes, ma'am. It is required.
It's required. Why?
for getting,
Ma'am,
ma'am, for getting
Yes, yes.
accurate or correct information.
Accurate or correct information. Okay. Otherwise, suppose we don't have the data, then how can I get the correct information? I don't have the data. I have some missing values. Data cleaning is required. I got the answer. See, for example, let us, when we were child, okay, when we were child, we used to learn from things, right? Your mother or parents teach us things, right? So suppose there was say for example, I'm writing alphabet, okay? They always show us how to write the alphabet. Now, if the letters are not given or not taught to us writing properly, what will happen? Finally, in my brain,
we might get
think
a
my
wrong.
brain inside, okay, we are learning, yeah, the letter A is this only, not the prop. Actually, we will have a different C. That means some garbage was in, so that garbage out, the point we see also would be a garbage thing. Okay, so when there is noise or some missing values, or if the mathematical model is not able to help us to get the proper thing, why, how can we predict it correctly? For example, take the healthcare, which is very, very much precise in giving the solutions. What happens if there is a point where one of the vital is not considered for the disease prediction? What happens? The model learns wrong thing, or some abnormal values were taught, okay, were given for the training. What happens? We will not get the correct accurate answer, which leads to other complications. So obviously, data cleaning and data pre-processing is one very larger step. We would say we call them as data engineers. So that is actually required. Okay, so whenever we download the data, or when we are doing a primary data collection also, we have to see whether the data is clean. And there are certain processes. I'll go after showing this presentation. I'll just show the data cleaning process also, how we are doing it. So now here, data cleaning. So first thing, whether I have to see whether there is any blank values. Suppose in this they were like zeros or no entry values. I have to handle it. So I'll show you how we are handling that. Now replace the missing values. So we called it as a process called imputation. Okay. And imputation is nothing but finding the average. It can be the average, it can be the median value or a mode value, where we are replacing the null value with that particular thing if the feature is mostly wanted. But we have to make sure not much null values are there in that particular feature. If, for example, if I'm considering all the features like PM 2.5, PM10, NO2, okay, nitrogen CO, all this together, and equally all features are important in contributing to my AQ1, I have to make sure there are not much null values in the column. Suppose CO1 is having larger null values. Please omit it. Please don't use that, because that is not going to help you to find out the quality index. Okay. Yeah. I will detail on that also. Now, remove duplicates. That can be one possibility, multiple entries. Okay. What happens is when a lot of duplicates appear, the learning also, again, learning also. For example, I have image, for example, computer in computer vision or image processing, if you take, I have 10 images of a person and only one image of another person, training it to a model. Something, what happens? More weightage is given to that 10 images of the person, right? So it's duplicates and more will be learned. The model will learn more on that. Imagine your mother is teaching you a letter A than teaching you letter C. Your brain will be learning more on A than identifying different types of C there. Okay, bias. Now, the next process is descriptive analysis. What is happening actually with the data? What is happening? So I just used average, max, and min. Now, city-wise analysis. Since I have the data in the last data, when I said about water, there was block A, block B, block C. Now, when I got this data, the thing is, I could understand that there are multiple cities. It is not on different cities. Now I have to find city-wise. So what can we use? We can use pivot table to understand what is the city-wise contribution or comparison on this data. Now see here. Yeah. So what does it tell? What does it tell? It tells about the pollution in the index. And with this, can you understand which city is having the larger AQI? Which city is having the larger AQI? If we could see the values, should I assume it?
Ma'am, Delhi.
Yeah, Delhi. Delhi is having the larger AQI. And
Delhi.
yes, it's Delhi. Delhi followed by Mumbai, then followed by Bengaluru, and then followed by Chennai. And the least polluted, according to the data set, is Kolkata. See how beautifully we are showing the numbers. Okay, so this is with 100 rows. Imagine if you're doing research, your minimum rows would be like 1,000. And we cannot always tell about the features also. Sometimes we get interesting data set where the column names will not be specified, especially when we work with some medical data. We had received a data set where is like column 1, 2, 3. We were stuck with that. What is that column standing for? We don't have the specific name, but then we have to observe, is that column contributing to this particular disease? What is the outcome? A person is detected with the disease or not? Now we have to find what that variable would be. Okay, and some companies give us the metadata, not a problem sometimes. But sometimes if in Kaggle also when we download, the name of may not be present. So we have to see how each feature is contributing. And let's not use the features which are not contributing. Okay, so that over what to say, experience only, we'll be in a position to tell, should we take it or should we not take it? Again, coming with, once you get the data, love the data, spend time, observe what kind of values are there. So that is why we are even using this average, max, and min, just to know the range. Very simple thing. You can tell a story along with this, right? The maximum value of AQI ranging from this value to this value. That itself is giving up audience the understanding about what type of values are there. Okay. Now, this comes to two things. Can you see the sum along with the three columns. What are they? Moderate, poor, and severe, which shows the health conditions, health category. Okay, so here obviously when it comes to the more polluted, what happens? They will have the larger or no a severe, very poor health or a severe category or a moderate average category. So you can see or compare the health condition. So here I considered three things. What are they? City, health, and the AQI. Okay, three features together. So this is also using a pivot table. Okay. So we are able to identify the most populated city, and it will help us to understand what the where to involve. Say, for example, policy making. If you're showing it, the health and the AQI is compared, right? Health and AQI is shown together. Now, government will think about some policy, what can be given here in this particular city, what to be notified. So we get some awareness sessions. There are some activities the government takes for the killing of, for the pesticides, then mosquitoes, etc. And then more on to the checkups. Okay, they involve the policy based on this data. Now, health impact analysis. This is by counting how many are in the severe condition, how many are in the good condition, how many are in the moderate condition. And here the trend analysis. Obviously a line chart where I've used the date and the AQI. So it's a fluctuating thing, and even you use a trend line in the line chart, it will give the actual trend or the possible trend required. Now this is also a scatter plot. So these are few analysis done. Now I've used the color coding also in the same data for showing the zones. Okay. Zones like which is having the risk values. Okay. So coloring code also used. And yeah, now here one thing I would like to tell about the forecast. Yeah, forecasting and predictive analysis, where no the data will be able to forecast a sheet. Sorry, data will be able to, we have to use forecast sheet, but here I was not able to do it because my data is not in a regular interval. So that you can modify or you can transform. That is where that information comes. Transform the data, bring it to the regular intervals, and then you can forecast. Okay. I showed about two data set, that is air quality and water. And now just moving back to the presentation on introducing some types of errors that can be possible. So as we said, data is prone to errors. Now, when we listen to this voice, my voice, do you think there is a noise in between? Or is it only the data getting transferred? Any audience? When I talk or when we listen to some music, do you think that there is noise? There will be noise. In similar way, there can be errors. That noise is actually an error, actually, right? We don't want that part. We wanted to remove that part for our to get the actual content, right? Actual music. Okay, so a lot of noise is there when we consider the data. So, two key types of data errors are interpretation errors. Okay, interpretation errors where this value, for example, here you can see the age is 312. And do you think that that data is actually possible? It is not possible. It can be an entry error, right? When I entered or when someone entered, some user entered, it can be an error. So such errors need to be removed. Okay. Next thing, inconsistency errors. For example, this is one of the errors that usually occur when we give the surveys or questionnaires. Okay, for example, when we ask for the gender, some people will write F, some will write female. Okay, and also when we ask for the money, the currency, it can be of different types. Now, the third example, India. India represented in three different ways. What happens is each entry becomes each country. Okay, or that female F and female will become two genders. Okay, so the data source will have the mismatched representation. Okay, I've not seen much that in Kaggle, but I am not sure about the other types of organizations when we, because some organizations give us the secondary data after them collecting from the users or the clients. So sometimes around that may happen. So if we are also giving away the questionnaires, or we are taking some interviews, or what are we, the way of collection data, we should be in a position to collect it in the same representation. So why this matters? Why the error matters when we come to the data? So it makes data merging difficult, leads to duplicate or incorrect grouping. That is the major thing, and confuses both human and the algorithms. So the best practice would be validate data during the preparation and use standard formats, and we have to clean that data early to avoid the chaos later. Okay, so for example, equitable education policy design. We circulated one questionnaire where we wanted to know about or decide about some scholarships or anything. So most of the values in the parental education was unfilled. Okay, so the use case can be government and universities can accurately identify the first generation learners and students from the low education household. This is not for nothing but for the targeted scholarships and the fee waiver system. Okay, so without cleaning, what happened? A lot of the students, needy students, were invisible. That their data was not considered, and when a policy is made in such a way, it will not become an inclusive, because a lot of students who really are eligible to get the scholarships will not receive it because of the uncleaned data. And with cleaning, the policy becomes inclusive and data driven. So that is one example why the data cleansing is required. So I used to refer a book on the principles of data science, where they've given beautifully how this need to be handled. Okay, so mistakes during data entry, it has to be observed, the data need to be observed, and then manual overrules are required. For example, I'll tell about manual overrules. For example, suppose uh, in a feature column. Okay, I showed you a data set. Now you have an idea about how the features appear. Suppose in a feature column, these four data was there: good, bad, good, or bad. Unfortunately, we know only two are there actually. But on entry, it made the 15 people or 15 entries were like Godo. What happens now? Now it becomes four types of the values, right? So manual coding or manual decision need to be taken. And then what have we done? If X is equal to Godo, we are replacing that to good, which now again goes back to the previous, the good, the actual value. So that is why we have the drop down options. So avoid text entries in maximum questionnaires. That would be the best thing where we can, and make the fields mandatory. It will help us to avoid this types of mistakes. Now, another type of error is redundant white spaces. When we enter unwanted, we always have a tendency in the keyboard, like no, we type and then press a space, which creates as another value. Okay, so in Python, when we take the data set, we can use the strip function, okay, which actually removes all these leading or the trailing spaces. And sometimes around the string cases, there's also another mistake which usually during the manual entry we make. Brazil and Brazil, though both are same in the view of a user, it has taken it as two countries because only of the string. So what can we do? We can do some operations or a conversion, case conversion operation to make it a single one. Okay. Now, when I said about, I've told about the outliers. Okay. So here, when we see the normal distribution of data, when a teacher is evaluating the marks and finally showing the results, it's a normal distribution for the second figure, second uh, graph. See, there are a few points which is away from it. Okay, this we call it as an outlier. This need to be observed and then decided. Okay. For example, in a salary, if we can calculate the salary or find the salary, maybe few of the employees are getting a higher salary. That can be based on their experience or some other features or added attributes to them. Okay, so that we may not have to consider for the prediction actually. Just omit it, and because that's a very rare case that happens, so we can omit that outlier. But in the case of diseases, we cannot do it. In the case of defect detection, we cannot do it because that can be something which need to be looked into. Okay. Earlier, when we learned the subject data mining, we used to see one example like when in Kashmir, there is a type of vehicles which moves around always. But there are when captured in cameras, if we see another type of vehicle coming through in that boundary, that need to be looked into. It is not omitted. It need to be looked into because it's some threat that is happening. Because only a type of vehicles happen. That this long back I have heard that example, but I'm just trying to reiterate during this, when I use the term outlier. Now, second thing, next thing is dealing with missing values. May not all the missing values are errors. So we have to fix. There are many types of errors that can happen. I've shared this PPT to Dr. Neeta. You can just collect it and just see because I think we are running near to the time. So there can be different types of data collection where there are missing values. So if we are not making a mandatory field, what happens? The human tendency is to not fill the data in that particular, especially when we come the age or something. And there can be some field which can be calculated from the other features. Example, from date of birth, we can have the age, right? So normally a question comes, they are collecting the date of birth and why the age. Then if it is not mandatory, we will not fill it, right? So when I wanted to calc or find the risk disease prediction, if age is mandatory and if the age is not calculated or age is not collected, that becomes a missing value, which is actually required. Okay. Now, respondent behavior, it is another reason for a refuse to answer for some sensitive questions. And there can be human error, there can be the value if we fetch from another system to our database or our system, there can be some data lost. And sometimes it is not mandatory. So many types of reasons are there for no missing data. Now, we can have the data cleaning and pre-processing. What can we do? Okay, so few examples are remove the blank spaces, validate the ranges. Okay, now ranges in the sense, for example, temperature, we can have a specific range, right? And age also, maximum we go till 120, not more than that, right? So ranges. Now marks, it is like 100, it is upon 100, so that there is a range 0 to 100. So that we need to fix before we give the data for the further modeling. Okay. Now, standardize the formats as we saw examples for different formats of the same data may be appearing, so we have to convert and fix it. Now handle the missing and sensitive field, the noise filtering, gap filling. Okay, especially when it comes to sensor data, lot of missing values. When it comes to streaming of the data also, there can be data lost. So how to observe or how to fill it? If it is a long gap, we will not be in a position to fill that lost data. So some process need to be done. So a lot of research is happening in that particular area also. Now, healthcare records, clean, inconsistent and incomplete data. Then satellite, the cloud removal, missing pixel fill. For example, we had one project where the fog detection, we got the data from Indian Meteorological Department in Pune. So the thing is, the clarity of the image was too blurred because of the fog. So now we had to do a pre-processing where where the fog is being removed or no suppressed, and the clarity on the runway need to be. It was for a aviation department actually. So runway need to be clear. So there are a lot of image processing techniques also being done. The same way for any structured data, we can have its own no pre-processing techniques. So that is the study on it will help us to understand. Sorry for the typo there. I have written pre-processing. I just saw it pre-processing. So here another method is omit the values. If a particular column is having lot of null values and we are not able to we are not getting any information out of it, just remove it. Remove that because it's not going to contribute for our insights. Okay. Then sometimes around we can set it as null value. But no, I will not suggest it for no very sensitive solutions, and and impute a static value. Okay, imputation means either replace the null value position with either mean, median, or the mode. When it comes to quantitative data, we can use mean or median. When it comes to categorical data, use for the mode. For example, gender. More replies or of the survey was from female. Then replace that. If a person has not filled that gender field, what happens? We can replace that with that mode value. Okay, which gives a more possibility of yes, this is more probability of a female. It would be a female. Okay. So, and sometimes around through our experience on modeling, we know the value. Okay, so that can be replaced. Now, so as I said, the imputation, we have to choose the right technique based on the context of the data available. So my suggestion is catch the data errors early, and otherwise what happens, garbage in becomes garbage out. And the next process, so hope I am clear with the data cleaning. So we got the data set. We have to observe whether there is any data to be cleaned. Both the data set we saw is actually clean data. There is no null value, there is no duplicate, and almost all the fields were filled. Okay, data is cleaned. Okay, now if we wanted to transform, or as one of the participants asked, if we wanted to calculate some value, okay, we can calculate and add that to the particular data set, which can be used for the modeling later. Okay, now next is after the data being processed, we go for the exploratory data analysis, where we are going to be a very, what to say, data detective, and we should be able to understand what is actually underlying. Is there a particular pattern in the Excel sheet when I showed? Is there any trend that is happening? Okay, what is the descriptive analytics? And we have to use the graphs to show how the data is flowing, because large number of data rows will be there, where we should be able to discover. Okay, so three things: discover the pattern, outliers, relationships, and the trends. This will help us to understand, okay, is there any particular pattern with the flow of the data. So just for EDA, we have to be very curious. We have to be very curious, seeing that what can be the underlying thing. That is why I said we should be a data detective, and we have to ask the smart questions and see the what is the actual underlying picture in it. So when I get just 5 columns of data on water, the questions to be formed, the research problem statements to be formed should be in such a way that we are extracting or pulling out the maximum data underlined or the story underlined with the data. So for exploratory data analysis, we are using the graphs, histogram, pie charts, etc., etc. Okay, so these can be different ways of charts. Okay, we are using. And the next process is the data modeling, where I'm going to use the prediction. Okay, I'm going to get the prediction, and finally the presentation and automation. I just wanted to share a collab where I will demo the same air quality one. Dr. Neeta, I'll finish it in 5 minutes. Okay, I know next session also is in line.
It's
Yeah.
okay, ma'am.
Yeah. So this is about, yeah, I've shared a collab where I've used the Python coding. So the problem is urban cities experience fluctuation in the air quality due to traffic, in industrial activity, etc. So here we have considered these many columns. Okay, these were the features, or we in different areas we use different words: variable, feature, attribute, etc. All these are the same. Okay, so here I've used the digital tools, and first when we get some data set, okay, first we get some data set, it is our duty to observe that. Again, I'm repeating. So here we can see the range, everything, and there is a function in Python which gives a summary, which describes, okay. So this is the basic exploration any person, once you get the data set, a structured data set, understand the data. Okay, so this function, that I'll just zoom it. Yeah. Yeah. So here, the first one, we have done the summary, that is getting the data. DF is the data frame. In Python, we use that structure. For the structured data, we take it as a data frame. So we get the information. And here in this information itself, we can see whether there are null values or not. See here. So I have in this, there are 46 rows, and all the values, the data set is clean, that there are no null values in mine. And it will also show the data type, whether it is quantitative, okay, whether it is categorical. Okay, so all this data will be seen there. And excuse me, and then we get dot describe will help us to understand the details about, or a summary about each rows. Okay, and these are certain EDA part which I've done. Average PM 2.5 level per city. So as I said, there are these cities and health categorization. Sorry. So see, this itself gives us information. In the records, the more entries are on poor. Okay, followed by severe and then moderate. So the good entries are less actually, which shows it is a concerned problem. Okay, now coming to the trend analysis, how is population changing over time, taking over months? Okay, this shows it's getting fluctuated, right? And in certain months we can see it's coming to a very low value. September, June, the pollution is going down. Now coming to city-wise pollution comparison. Okay, so AQI, air quality index distribution. This is a box plot which help us to understand the range actually. So there is a term range here in the quartile range also. So that mean average, and this zeros, like points. Okay, so not zeros. The points show they are the outliers. Means it is not in that particular range. It is exceeding or depreciating with a lesser value. Now coming to the diagnostic analysis, why is it happening? Okay, so now the question would be, why is AQI high? And is there any factor which is mostly influencing AQI? So we have all these fields actually, PM 2.5, PM10, NO2, nitrogen, CO, okay, and AQI. And in it, we could see that PM 2.5 is having a higher correlation with AQ1. So this is the correlation matrix. If you see, yeah, if you see PM 2.5 with AQ1, the points are 0.71 and PM10 0.69. The other values, that is NO2 and CO is having lesser correlation with the this factor AQ1. My target variable is AQ1, right? In AQI index, not AQ1, AQI index. So the interpretation would be PM 2.5 and PM10 shows strong correlation with AQ1. So we cannot omit these features, but the other ones it can be thought about. Okay. And this shows the relation. That means there is a correlation with the increase in PM 2.5 will really affect the AQI index. Okay. Now, for the prediction, we have to use the training data or testing data and then use some algorithms. So then there is no time for it actually. So regression algorithm, classification algorithm based on the problem statement we have to do, which helps us to give the predictive analytics. Okay. So hope you got a flow about how we are trying to develop these particular sustainable solutions using the digital tools and the data analytic process. So we went through how we are storing the data, how we are collecting the data and storing it, and what all things can be performed on a simple data set, and how are we trying to bring out the stories from the large amount of data what we are getting, and bringing that insights to the action decision making. That is a final solution. And yeah, decision making or some product which does the smart process. Okay. So I think I've kept the time. Thank you so much. Any doubts? So this is one graph also we would like to show, where the most populated polluted city is being shown. We have used the graph tool. Yeah, it's a vast area actually. But I think I've introduced to you few tools and the few process that actually have no is used for for developing the sustainable solutions. Thank you all for your patient listening. So
Good
if
evening, ma'am.
yes, yes, sir.
I have a doubt regarding that data processing.
Yes, sir.
There are so many technology used for data processing. Is there is any criteria for using any data processing technology to particular category of data?
Can you give one example or what you were facing? So I'll be able to give a proper solution for it.
Primary data, the source of data, there are so many type of
Hmm.
data, primary data and the
Yes, sir.
secondary data. Is there
Yeah.
is any particular criteria for using data processing technology to primary data?
Uh, is it the way you're collecting the data needs to be a proper way? Is it that you are asking? Or processing in the sense you wanted to create some variables or something? Is it, for
Create
example,
variables.
so
We want to
yeah.
create some variables.
Yes, sir. So that based upon that is again based upon the domain of data what you're collecting. For example, you're doing something on the policy making. Okay, so
Okay, okay,
you are giving a questionnaire to it can be a simple questionnaire where you're getting the details from a set of people. Okay, so when you go for a policy making, if it is concentrated on a particular category, for example, we have children, we have teenage, we have no adults. Okay, so suppose of
okay,
the if your policy making is only for adults, the first thing is get the data only from that category.
okay, okay,
Okay,
okay, okay.
somewhere around we wanted to do with a mixed. For example, a lot of projects came with edtech companies. One of the reason for the failure is, I would say, so for of not all companies, of some of the edtech is the way they collected the data, the category or the population they collected the data. So
Okay.
population matters. Population in the sense category. If I go for a school student and creating a tool for a teenage, it fails. Okay, so from there onwards, we have to fix on what to which population am I concentrating for this domain. Take
Okay.
agriculture. Okay, take agriculture. If you wanted to get it from farmers of a particular area, the questionnaire should be in such a way that we are trying to avoid the incomplete data or anything. So
Okay,
if
ma'am.
there is incomplete data, then suppose by default, if I have lot of incomplete data, please don't go with that data set, because that is not going to give you anything. But somewhere around we are able to get some insights. Okay, then handle the data accordingly. As I said, for the quantitative data, go with the imputations instead of just avoiding keeping it like a zero value, etc. Okay, and it's all, sir, experience when you observe the data. So
Okay.
it takes some time for you to understand what it is. So I cannot tell that for the student data uses technique, for the medical data uses. It depends on the domain where you're doing. Hope I
Okay, ma'am.
answered.
Thank you. Thank
Please,
you, ma'am.
please take care of when you collect the data. That
Okay,
will
okay.
avoid lot of our further works.
Okay, ma'am. Okay.
Thank you. So I'll just put my email ID in the chat. So, and also the phone number. So if you have any queries related to this or further, no, just you can connect to me. I'm available at any time, or within a week I'll be replying to you. Thank you so much.
Thank you, ma'am, for the enlightening session. Participants are requested to post your questions in the chat box, or else you can unmute your microphones and ask queries. I will read out the questions on behalf of the participants.
Yes, ma'am.
Thank you once again for your active participation. The feedback form will be shared at the end of today's session in the chat box. Kindly stay online. To formally conclude this session, now I invite Mr. Jibin George, HOD, Department of Computer Science, and Nodal Officer representing MG University to deliver the vote of thanks.
Respected Dr. Lija Jacob, on behalf of the organizing committee, I sincerely thank you for delivering an enlightening session on digital tools, data analytics, AI, and smart technologies in promoting sustainable solutions. Your talk provided valuable insights into the role of emerging technologies in achieving sustainability and inspired us to think innovatively and responsibly. We are grateful for your time and meaningful contribution. Thank you, ma'am.
Thank you once again, dear participants and
Thank you, Jibin
core
sir.
committee. Thank you. Thank you. Yeah.
Kindly remain online. The next session will start shortly.
Good evening to all the respected resource persons, dignitaries, faculty members, and participants joining us from different parts of the country. Myself, Lima George, Assistant Professor, Department of Computer Science, hosting this session. On behalf of Shantigiri College of Computer Sciences, I warmly welcome you all to session 4 of AICT ATAL Academy sponsored 6-day online faculty development program. To formally commence fourth session, now I invite Ms. Jomol Joy, Assistant Professor, Department of Management, to deliver the welcome address.
Good evening to all. It is my great pleasure to warmly welcome Ms. Rashmi Rajama, a highly accomplished lead data engineer from the data integration team at F1G, a reputed insurance company in the United States. With over a decade of experience, Ms. Rashmi brings deep expertise in ETL process and has played a key role in designing and building robust data warehouse and data integration solutions that support enterprise and customer data platforms. Her work enables reliable and scalable data access, driving better decision making, improved operational efficiency, and enhanced customer experience. Currently, she focuses on developing advanced data products and defining best practices that strengthen the organization's overall data ecosystem. We are truly honored to have Ms. Deshmi Rajama with us today. Please join me in giving her a warm and respectful welcome. Ma'am, it's over to you.
Hello, everyone. Are you able to hear me?
Yes, ma'am. Yes, ma'am.
Okay. Thank you. Thank you, Miss Lima and Miss Jomol. I hope I got your name right. Thank you so
Ma'am?
much for this. Yes. Go ahead. I can hear you. Please go ahead.
Yes, ma'am. Yes, ma'am.
Okay. May I continue?
Sure.
Okay. A very good evening, respected Father Matthew, Principal Professor Dr. Jose Joan, Dr. Neeta Thomas, Director of MCA, and Mr. Shibu Abraham, distinguished faculty members of Shantigiri and other reputed institutions, and all the participants who have joined today. It's truly an honor and a privilege to be invited to speak at the AICTE ATAL funded 6-day online faculty development program on green transitions, leveraging digital tools and strategic leadership for climate resilience. I sincerely thank the management of Shantigiri College of Computer Sciences, a NAC accredited institution affiliated to Mahatma Gandhi University, for their confidence in me and for this gracious invitation. Your inspiring vision, Awakening to the Future, beautifully captures the responsibility we share as educators to awaken this generation to face the challenges of tomorrow with wisdom, innovation, and ethical commitment. I would like to congratulate the college on its commendable Green Campus and Go Green initiatives, which reflect a deep commitment to sustainability through renewable energy adoption, ecological conservation, and responsible resource management. These efforts strongly resonate with today's discussion on energy stability through smart data management, and I'm delighted to be part of this meaningful academic journey with you all. Thank you for your patience, and please excuse any unintended mistakes in the presentation. Some aspects are based on my current understanding of the topic. Without any further delay, let us begin. I will be sharing my screen in a bit here. Please let me know if you're able to see. Are you able to see? Yes. Are you able to see?
Yes, yes. Visible.
Yes,
Okay.
ma'am. Yes, ma'am.
Okay. I'm going to share my screen. I already shared, and I will begin the presentation. Second here. Okay. Okay. Yes, sorry. So my topic for today is energy stability through smart data management. And here are the topics that will be covered under the presentation. What is energy stability? And it's important in smart data management. Data management versus smart data management. What is the difference between them? What is energy sustainable data management? How smart data management supports green initiative, how smart data management ensures energy stability, what are the supporting green initiatives that are that is there in the world today or people are following them, and what are the emerging sustainable data management techniques. What is energy stability, right? I don't think the people in this gathering today have any questions. It's a reliable power supply, right? There is a balance between demand and supply. There are minimal outages and we have resilience during climate events. Okay, so that constitutes the energy stability. Give me 1 minute here. This is in my way. Okay. Okay, I got it. Yes. So what is the importance of energy stability in terms of data management? Data management or the energy stability in terms of data management is crucial for optimizing consumption, reducing cost, improving sustainability. Effective energy data management involves collecting and analyzing energy related information, right? How much energy is created? How much energy is getting wasted? Do we have enough? All those sorts of information. Implementing robust energy consumption monitoring, utilizing advanced technologies, addressing challenges like data quality, which was covered in the previous section by Professor Lija, real-time processing, and data silos. By leveraging these strategies, organizations can better manage their energy data and contribute to a more sustainable energy future. I know all of these concepts may be a little bit not familiar. And while we go through the slides or go through this presentation, it will all get clear. Okay, let me go to the next slide here. Okay, so what is data management? Data management is the traditional practice of collecting, storing, organizing, securing, and maintaining data. So it is accurate, available, and reliable for operational and analytical use. Now, in my industry, as I was introduced, I work in an insurance domain, right? Or any let's take any background. So what does collection mean? So in my case, in insurance industry, we have a policy admin system, right? And that admin system sends data in the form of files. So that files are at the end of the day, they processes their batch cycle and send data to us in flat files. It can be .csv, it can .txt or the COBOL files, right? So that is collection. Now we have to process the data. We load those files. We have jobs, which I'll be covering in the core components down there, ELT, right? We have processes that reads the file, loads the data, stores it in the database in the form of tables, right? Organizes it. What is organizing? Organizing means normalizing, denormalizing. You are getting one file, but that data can be split into multiple tables based on the content of it, right? You're securing the data. Not everybody should be given access, right? There should be people of certain groups that should have certain type of accesses. Nobody should have delete access. People can have view access, but they should not be given a read access on Aadhaar number. That's highly secure, right? Maintaining data. What is maintaining data? You are, as in today's world, data is like huge, right? You have to maintain it. You cannot keep storing the data and not maintain it. You have to make sure that when you're querying the data in the table, Your queries are running optimized. You have to create indexes. You have to remove duplicates, right? So that's all under that topic. Now, what are the key characteristics? Key characteristics of data management focuses on data lifecycle. We covered that. Ensures data quality and security and compliance, right? Largely rule-based and manual. When we say manual, what it means is depends on predefined rules, and human intervention is needed to control, monitor, rather than intelligent automation. There is no automation there, right? It's manual. Somebody had to run the job, somebody had to do this, they have to monitor the data, all those stuff. And data management is reactive, that problems are fixed after they occur. People only notice it later. Like your consumers, they might report some issues, or your jobs are running longer than expected. So after it happens, that's when you realize that, okay, there is a problem. What are the core components? The core components are databases, data warehouses, data lakes. What is a data warehouse? A centralized repository designed to store large volume of data from multiple sources, enabling efficient querying. It supports business intelligence activities such as data analytics and data mining. What are data lakes? They are centralized repository that allows organizations to store all types of data. It can be structured, which is a table, right? Semi-structured XML or JSON, and unstructured like audio and video, images. Those will come under the data lakes. So all those informations will be stored in data lakes. ELT and ETL pipelines, right? So what is ETL? ETL stands for extract, transform, and load. So when you get the data, when you collect the data, you extract the data from the source, right? You can transform it. You can change how it looks. The source system might be sending you some information, but for your company, you might need to transform it. For example, if I were to give an example in the address, like the address field, right? So the source system can say DR, which is for drive, and in your system, you can change it. You have some lookup table. You want to do some transformations, right? They might send a gender as 1 or 0 for the ease of transmission, but in your system you want to store it as male or female. So that is the transformation, and then you load it. So extract, transform, and load. Whereas the other one is you extract it, you load it, and then you transform it. So after you load into your database, then you transform it to the needs or the rules of your company. There is data governance and access controls on data warehouses, and we also do backup, recovery, and retention policies. How long do you want to store this data? When will you qualify it as state? Okay. Now let's come to smart data management. What is smart data management? Smart data management is an advanced, intelligence-driven approach that uses AI and machine learning, automation, and metadata to manage proactively and contextually. So when it comes to data management, that was reactive, whereas this is proactive. It can it can identify an issue before it can happen. Okay. Now, what is metadata? For those who may not be clear, metadata is nothing, but it is data about the data. If we were to take an example of the book, the story is a data, the title, author, page count, publication, that can be the metadata. If you take a picture, that is the data, right? But then where did you take it? What was the location? What was the date? That constitutes the metadata, data about the data. What that helps is makes easy to find, helps people understand and trust the data, and keeps the data organized, and supports security and privacy. Now, what are the key characteristics of smart data management? Uses AI and machine learning to automate the decisions and actions. What is AI? It refers to the development of computer systems capable of performing tasks that typically require human intelligence, right? So using AI, we are training the computers to take the decision, analyze the data, and predict something, suggest something. These tasks include recognizing speech, uh, making decisions, solving problems, and identifying patterns. Remember how when we log into any website, let's take an example of an ICICI Bank website, right? There's a software called a chat bot called iPal. Based on the time of the day, it will say good morning, good evening, and ask what you need. And it will try its best to ask you questions to get you the answers. And or even it can be a call center where an automated person might be talking to you. And if they can't, we keep pressing that we can get hold of a human, but as soon as possible, right? But then these technologies are improving and they are able to answer our query so that we don't have to rely on a human call representative, customer representative, right? So that's AI. Now, what is machine learning? Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve their performance without explicit programming. You don't have to do anything. You just have to provide them the data. It involves using algorithms to identify the patterns in the data and make predictions or decisions based on these patterns. I know in the previous sessions, we have covered data quality, right? Data quality is nothing but that encompasses the degree to which data meets the requirement of its users and supports accurate and efficient decision making. If I were to give the example in the industry that I work, the data that we collect from our source system, that is being monitored by a separate team called business intelligence team, and they note, okay, so this particular insurance product, we sell both annuities and life, right? And under those categories we have several sub products. So they check, okay, this particular product has a huge demand in the market, let's see, okay, or this particular product has not sold in last 1 year, let's see what our competitors are doing, what changes we can make so that it can be more appealing, right? Or come in demand. So that is data quality. There is a concept of data governance. What is data governance? It's a discipline part of data management that focuses on the quality, security, and availability of the organization's data. It defines some standards and procedures for data collection, ownership, storage, processing, and use. Okay. Let's see. What is sustainable data management? Energy sustainable data management involves optimizing hardware, software, and processes to reduce the energy use, using renewable sources, leveraging AI for efficiency, focusing on green cloud. I will be coming or explaining this topic of green cloud a little bit later in the slides. Data lifecycle management, we just saw that, right? Storage and archiving, deduplication, smart cooling, efficient infrastructure to minimize power consumption and carbon footprint. All of these topics have been elaborated in my upcoming slides. So we'll go to the next one here. Okay. Now, what is environment friendly data management? Environment friendly data management, often called as green data management, has evolved from simple energy saving to a holistic approach, combining AI driven automation and data minimization. Now, what is green data management, right? Data management in ways that reduce environmental impact, especially energy consumption and carbon emission. How can we store as an industry, you as a different business organization, right? Retailers and insurance industry, banking industry, they have so much data. How can they reduce or store their data in an efficient way that they can avoid the energy consumptions, right? Carbon emissions. Or let's say how in another way I can define it is handling data efficiently. So IT systems use less energy and are more environment friendly. Now, why is green data management important, right? I'm not sure if everybody here is familiar with the concepts of data center. Data center is nothing but a place where all the servers are kept, right? It's a collection of or all the servers which can process the data, and that is the data center. Now, the data center consume a huge amount of electricity. Remember how when in the old time when we used to have a CPU, or even you might have noticed in your laptop, your fan keeps spinning. It's hot, right? If you keep it in your lap, you'll understand that it's hot. That's generating some energy. So think about thousands of computers kept, right, in the data centers. They consume a huge amount of electricity. They have to be connected because any time of the day, anybody can go from different part of the world and try to access the information. So you cannot turn them off like we turn off our computer. At the end of the day, these data centers, they can't turn off any of their servers, right? Growing data volumes increase carbon emission. The more data you store, you need more memory, you need more servers, you need more processing to access the right data, right? Now, what's the example here? So, a large online retailer store has years of customer information and transaction data, right? It is frequently used data, the more recent data, last 5 years, which you might need, or there can be a category of data that should be kept on a fast system, right? Old or rarely used data, like my customer system from last 10 years, the people whose policies have ended several years back, the products that we don't support anymore, right? All those can be moved to a low energy storage area. Duplicate data can be deleted, right? The cloud servers, they can scale up and down based on how much data you are utilizing. They will say, okay, there is not enough need today, not much people are accessing, or whatever, based on whatever criteria it is, they can scale up and down. And if the data center is running on a renewable energy, like a solar energy, when possible, that's the best. So these all are the examples of green data management. Oops, sorry. Now see how smart data management supports the green initiative. Smart data management has become the brain of energy sector, transforming volatile renewable power into a stable, reliable resource. By using AI and IoT to process massive volume of real-time data, organizations can balance the grid and accelerate green initiatives. So what is the use of AI? So AI can predict the demand spikes and supply shortages. Okay, it can forecast that the renewable energy generation based on the weather. Oh, today is a sunny day. So the AI can say, okay, in the last, it has the data. It has the data within it. So it can, okay, last time this was the temperature, right? And this is the wind. So how much energy can be generated? It has that information. It can give you an idea so that you can plan. If you need to rely on the regular fossil fuel generated electricity, or if you can rely on the renewable energy. It can detect failures before they can cause outages. Now, what's the role of this IoT, Internet of Things, right? There can be smart meters, sensors, connected energy that can continuously collect the data. Even though we are using electricity, if I have a smart meter in my home, my electricity provider can notice the spikes, or in the whole community, in the whole residential area, they can see what is happening, right? So that's the continuous collection of data. They can see the energy demand, power generation levels from renewable source, grid condition, voltage, frequency, and load. They can check the equipment health and environmental condition. They can also have the live view of the grid. So these are some aspects of how data management can support the green initiative. We will cover any questions towards the end. So I would like to cover the material first, and we'll go to the questions next, okay? So that's why, okay. So how smart data management ensures energy stability? Real-time load balancing. AI-driven smart grids analyze fluctuations in supply. They can monitor the power grid and demand to dynamically regulate energy distribution. They notice, okay, there's a problem here. They can redirect the energy from other sources. Predictive grid self-healing. Machine learning models now detect subtle anomalies in transmission lines and transformers weeks before the failure occurs, allowing for proactive maintenance that maintain stability without service interruptions. So based on the data that's there, they can notice, okay, this particular line, there is some problem. The data is not flowing as usual. There is a problem. So then that can generate an alert, and it would include the people. An email notification or a text message can go to the people who might then have to look at what's going on and fix the issue before you have an outage. Virtual power plants. Smart data management coordinates thousands of distributed energy resources like residential batteries, electronic vehicle chargers into a single virtual plant. These systems autonomously sell flexibility back to the grid to stabilize the volatility during peak demand. So you have an electronic vehicle charger, right? You have during the day, today was a very sunny day, the electricity has been stored, right? But in my residential battery, it's running out. So this solar batteries can then give power, right? They can sell the power. They can give some, because they don't, I mean, that's a connected network. So they can interact within it and share something that is needed, right? So we can balance. What's the high accuracy demand forecasting? By integrating weather data, historical patterns, and market fluctuations, advanced models achieve 96 to 98% of accuracy in forecasting energy consumption, preventing wasteful overproduction. Okay. Let's come to the point of supporting the green initiative. What can be done? What can be done by these data management systems, the cloud technologies, right? What does supporting green initiative looks like? What does it encompass? So the first point that's mentioned there is seamless renewable integration. Smart data management overcomes the variability of the wind and solar by forecasting generation yield and adjusting the grid consumption patterns accordingly, reducing the reliance on fossil fuel backups. So as I mentioned, on a sunny day, the AI, the systems, all these providers, they have years worth of data. So they know when the wind is with this speed, the temperature is this one, with the sun from 6 a.m. to 6 p.m., how much data can be generated, how much electricity can be generated from the solar power, right? So that is seen, and that way, based on that data, they can, okay, today let's utilize the solar power as much as possible before the switch or before using the regular electricity that is flowing us from the transformer from the grid. 24/7 carbon free energy. What is that? Organizations are moving beyond annual offsets to hourly matching of consumption with renewable generation. In the past, they used to monitor all these things at a annual basis, but now with real-time data available, we can do a hourly matching. This ensures that even at midnight, a facility is powered by stored wind or hydro energy rather than on the solar credits from the previous day. Energy as a service. Smart meters act as a gateway for peer-to-peer renewable trading within communities, allowing individuals to sell surplus green energy directly to the neighbors, maximizing local renewable use. So in our community where we stay today, we have solar panels, right? So what they say is, what the provider told us is, so you would generate solar power, right? That would be stored in a battery. If it is more than what is you need for your consumption, you can also sell it, right? And that would reduce your electricity bill. You might have credits and you may not have to pay your electricity bill for a long time. So that is known as like selling an energy as a service. You are sharing that with your neighbor, your community, right? What is decarbonizing the transport? So data management optimizes electronic vehicle charging schedules to occur when the renewable energy is the most abundant, which is during the day, right? During electric fleets into a massive smart battery that supports a cleaner electricity system. Last but not the least, waste heat recovery. Data centers use thermal management to redirect the 40 to 80% of the waste heat to nearby hospitals, right? Or district heating systems, supporting a circular energy economy. There is examples in my next slides that, for example, in the data centers, the heat that is generated from these servers running throughout the day, that energy is then used at a different place to heat a community, to heat a residential area, to heat your home. Think about it. So it in the data center, the heat energy is a waste, but we are using that waste product in more, better ways. Heating the homes where people cannot afford the heat, right? Using that heat to heat a swimming pool. More to come in my next slides. Now let's see data center and infrastructure. Data centers should be energy efficient hardware. Yes, use low power servers. What can the data centers do to follow this green initiative? They can use low power servers. They can use solid state drivers and networking gears. They can use green cloud, migrate to cloud providers with the strong sustainability initiatives. You can see on the right side, right? These cloud providers, Google Cloud, Microsoft Azure, AWS, they all have some goals. Google Cloud claims to be carbon free by 2030. So let's support them, right? When you choose your cloud provider, let's make the right decision of supporting a provider that is working for the cause, a good cause, right? Now, smart cooling, implement AI to optimize the cooling, detect the hot spots, and adjust airflow. So in a data center that have hundreds and thousands of servers and computers, analyze where the temperature, like use AI to check where the temperature, where is the hot spot, and only cool it instead of running the AC, throughout the day, cooling it throughout the data center. If you can identify a spot that is more hot, or those servers are running for a long time, you can specially adjust the temperature in that area of the data center instead of running throughout the data center at one particular temperature. Power management, utilizing built-in server power settings and optimize power distribution. Infrastructure optimization, consolidate underutilized servers and use efficient storage solutions. Okay. So Microsoft Azure, it says that its primary tool is emission impact dashboard, and they claim to be carbon negative by 2030. AWS says their tool for this green sustainability is customer carbon footprint tool, and they say that net zero carbon by 2040. What is net zero? Net zero is how much you're producing. You can't avoid, and in the data centers, right? All these cloud providers, they cannot avoid the negative effect, like the heat energy and all the wastage. But if they also do something to utilize the heat energy or the waste from these data centers, they can that is known as net zero. How much you produce, that is how much you utilize, right? Okay. Let's see here. Okay. Now let's see, excuse me for a minute here. Okay. What are the data management best practices, right? Data management life cycle. You have to focus on your data management life cycle. You have to archive the old data. You have to clean your data. You have to delete the duplicates. Manage data retention to reduce the storage needs. Like the insurance industry example or the financial or bank industry example, there is a point, right? You don't need so much old data. You need it. You archive it. You move it to a different server where it is not accessed day in and day out. Why would you store the information of a customer who no longer holds an account in your bank anymore in your main server, right? So archiving the old data. We need it for audit purposes. Yes, you need all the data. You cannot get rid of it, but you can archive it, right? You have to maintain a clean data. You don't have to have a duplicate data. If we are a policy holder company, right, we will, if the same policy information is needed by multiple departments in my organization, they will use a centralized data store, right? They don't have finance department having their own copy, HR department they're having their own copy, right? Commission system having their own copy, the sales and policyholder portals having their own copy. So that all is duplicates, right? Unnecessary data. So let's try to move to a strategy where people are accessing centralized data. Data deduplication, we already covered that. It reduces the storage footprint and energy consumptions. Green coding. Choose efficient programming languages and optimize application for lower resource use. So I was surprised to see that the C and C++, the basics of our college education, the language, that is the fastest. Language C is classified as a green coding language. It can be compiled directly to the machine code. It executes very fast. It uses less memory and gives the developer control over the network resources. Because program written in C often finishes the task faster and with less energy, they consume less electricity, making them environmental friendly. So while we teach our class, tell them that I know today there are fancy languages like Python, Java, and so many other things. But C and C++, people are moving back to these languages because they support the green initiative, the green coding, right? Excuse me. Now let's see, what are the analytics and operations, right? What these can do. So real-time monitoring can use the smart meters, Internet of Things, to track the energy usage and adjust instantly, right? They can track, okay, solar energy is being produced at this time. Today is a fully sunny day. Let's switch to the renewable energy at the data centers versus the electricity. So they can make the switch. There are programs that can do that, make that switch, right? Predictive analytics. Analyze the historical data to find the trends and plan for efficiency. There is AI for grid optimization, right? Balance the energy supply and demand in real time for grids. So if there is a real-time connection, they can monitor and balance the energy supply. They can see, okay, today is a very hot day. People are going to turn on their ACs. So today we are going to have a heavy demand, right? So that way they can manage their supply based on the demand. Now, what are the organizational policies or what we can do to make people aware about these green initiatives or energy sustainable data management? Employee education. And it doesn't have to be an employee. It can start from the basics, our students, right? Or any company. Train the staff, train the students on reducing unnecessary data and sustainable practices. Remember how when we prepare a document for a presentation, just an example, even in my case, right? I have multiple copies of the document, right? I modify something and I say, okay, what if I lose that, right? So I create another copy. So when we back up a document on our computer, right, in order to not lose it, there we have to train our people to go back and get rid of that, right? You might even your pictures. How much pictures do you have? The same copy, right? One might be blurry, one might be always we just leave it there. I mean, we forget about it. But that is all consuming data, right? Policy implementation. Develop clear policies for data retention and archiving and disposal. So in our company, like I said, we get thousands, hundreds of files each day from our vendor, our policy admin system. So we cannot leave all those files on the disk. So the data retention for the archival strategy for our company is 5 years, right? So those files will be deleted from the main server and put it somewhere else, right? And they can be retrieved when needed. The third policy is renewable energy. Power operations with solar, wind, or other renewables whenever possible. Try to switch to the green energy as much as possible. Now, what are the emerging sustainable data management techniques? Right, which we all can follow, or which are being followed by big companies and which can be followed by even the small companies at a smaller level, right? There might be different things. So the first point there is data minimization and life cycle management. Minimize the data that you store on the main thing, right, on the main server. And the life cycle management, how you store, collect data, you use only the clean data. So the first subtopic would be eliminate dark data. Organizations are aggressively targeting on dark data, which is nothing but unstructured, unused information that accounts for over 50% of the global storage, to reduce unnecessary energy consumption. Something that you don't need, 5-year-old data, just move it to your secondary storage, right? Modular infrastructure. Data centers have shifted toward modular and upgradable hardware, replacing individual components like power supplies or processors instead of entire units to minimize EVs. Remember, so in today's world, right, our electronic device, say a mobile, a TV that goes bad, right? What do they say that when we go to get it repaired, people say that, oh, it cannot be repaired. You should better get a new one. So instead of that, we should in the old times, when our parents and older generations, they were able to get that exact piece replaced instead of completely recycling the whole stuff, right? So that's what the data centers are doing. They are coming back to the old concept of replacing only what is needed. Instead of just throwing away the whole thing, whole server, and creating the e-waste, they are using upgradable hardwares so that they can replace the individual components. Tired storage, which is nothing but archiving infrequently accessed data into cold storage or a low power systems that significantly lowers the energy needed for constant data fetching. Okay. Number 2, AI-driven energy optimization. What is AI-driven energy optimization? It can be predictive workload scheduling. AI systems now automate renewable aware scheduling, running non-urgent or high compute tasks during the peak renewable energy availability, that is during solar hours, right? So in our organization, we have daily data loads that runs at the end of the day, during the night, in US, that runs during the night in US. During the month end, the cycles run longer, right? But that is something that we cannot avoid. There are calculations done on the policies at the end of the month, at the end of the quarter end, so the policyholder can see the right values. But there are systems, right? There are jobs, there are processes which can be scheduled, right? Based on which are non-urgent, right? Which can be moved to a later. It doesn't have to be a month end. If it can be run anything, which can be postponed, then let's do it at a time when the renewable energy is abundant, when the sun is out there. So that way the organization can use the solar energy or renewable energy. Today we have a very good wind or high speed wind, right? At that time the systems that are powered by the wind, and they can rely on that, right? They can postpone their jobs. So predictive workload scheduling. So AI systems can predict, okay, today the day the weather is going to be like that, you are going to get this much solar energy created, and you can do this. So based on that, people can, or the jobs have been scheduled. Okay, if this like I heard about variables and all those stuff, right? So you can program it in such a way that when the threshold is reached, the job automatically triggers. You don't even have to go and start your job. Grid and load management. Utilities use AI and digital twins to forecast energy demands with high precision, reducing reliance on fossil fuels, spinning reserves, and minimizing wasted renewable energy. I heard the first speaker from yesterday talking about the twins, right? Digital twins. So that way for example, when it comes to data, right, you are not giving the real data, you can generate mock data. That way you don't have to worry that your personal information is getting lost and all those things. So it will save energy. It's all dummy data. There's a lot of data available, or AI can generate that for you. And we are mocking a situation, right? Okay, if this happens, how would it behave? Automated cooling. So modern AI native energy management monitors real-time thermal data to dynamically adjust cooling systems, reducing waste from static and non-adaptive cooling. Okay, so automated cooling mostly refers to the data centers and the heat, that energy that is generated there from the servers. Edge and decentralized computing. So what is edge? What is edge or decentralized computing, right? The proximity processing. The edge data center market has more than doubled, allowing data to be processed locally to reduce the energy cost for long distance transmissions. So the data is generated at one place, right? If I were to give an example, the data is generated in Nevada state. Okay, take an example from India, right? Think about it, that the data is generated in Jammu Kashmir and it has to travel all the way to Tamil Nadu or Kerala, right? So that much data is so that traffic, that all uses energy. That's not free. So the edge data center, what they do, that's a concept of reducing the distance or reducing the data transmission energy. So the less the data transmission energy equal to the less data movement, which means less electricity or lower carbon emission. Proximity processing analyzes data locally and sends only the useful results. So lower the data center load, right? Not all the information is transferred from one place to another. Only what is needed, right? Central data centers consume massive power and cooling energy. Minimizes the storage of unnecessary data. Something that is not needed, you don't store it, right? So what can be the examples? So let's take an example of a smart wind farm. Sensor collect wind speed and turbine data, right? Local systems which are close to where the energy is being generated adjust the turbine angles, Only summarized performance data is sent to the cloud, right? So you are making adjustment locally based on the data you collect, and only the summarized information is sent to the cloud for later analysis, right? Let's take an example of a smart traffic system. The cameras process the traffic locally, and only the alert and pattern are submitted to the main server. Okay, so the cutting energy use and lowering emissions and improving efficiency. That is what relates to the proximity, or what is meant by the proximity processing, edge computing, or another name can be near data processing. Microgrids. What are microgrids? Small, highly connected facilities which are increasing, powered by on-site microgrids and behind the meter generation to ensure reliability without overstraining the public grid. Okay, these are microgrids, are small local energy systems that generate and store and distribute electricity for a specific area, such as a campus, a hospital, and a factory, right? So colleges and campuses or hospitals, they can come up with these microgrids, which can use solar panel, and which can use the solar panel, or they can support their own. They don't have to get it from the main transformer in the city, right? When possible, they can utilize the power from their own grid generated from the renewable energy. And when not possible, they would have still have a connection to the main grid in the city, and they can get the data from there, right? How does this operate? It has to be connected to the main power, and it works independently also when the main grid fails. If there was a failure in the main grid, your microgrid can support your system, support your organization in those cases. In hospital, we cannot, we don't have an option. Power has to be always there. So even if there is a failure in the main city, you would, if you have this microgrids or batteries or the backup plan, that would keep supporting your uh, uh, offices and organization, right? How does that work? It generate the energy locally, as an example, like renewable energy based on the wind or the solar. Store the excess data. If more energy is generated than the demand, store it in the battery. Distribute the power to local users. Like I said, like if I have a solar panel on top of my roof and I'm not utilizing it, the energy providers give me an option, right? That I can sell the power to the local other users. That way they are also using the solar energy and not using the fossil fuel generated energy, which is towards the moving towards the green initiative, right? Sharing is caring. Switch to independent operations during outages. So when the main grid fails, if you have a microgrid, that you can go to an independent mode. You can utilize the data from the microgrid saved in the battery. Okay. Intelligent storage optimization. What is that? So that more focuses on the how we store the data, right? Deduplication and compression. Use data duplication and advanced compression algorithms to reduce the total physical storage footprint, allowing for more data per petabyte and lowering power consumptions. So that is a little bit fancy statement there, but it's as simple as that. Unnecessary data, duplicate data, same student information, why it has to be stored in the chemistry department, biology department, mathematics department. That's an example, right? So remove the duplicate in the policy admin system. Don't store separate data in finance, commission, and agent for the agents, right? Don't have multiple copies of the same data. So that's where my company is moving toward a data product strategy, which is more like a centralized data. Excuse me. There will be one central place of the data which is trusted, right? Everybody has approved, and that's a golden source of truth, right? Tomorrow you find an issue with the data at one place, you correct it, but other systems are still holding that old copy, right? Which is not correct. So that's where the centralized or deduplication help, right? Zero copy architecture. Adopt zero copy techniques that allows multiple applications to access the same data set without duplicating it, right? Saving massive amounts of energy otherwise spent on the data movement and redundant storage. To give you a real life example, we have multiple environments, right? In an IT industry, people have like development environment, a QA environment, a user acceptance testing environment, and a production environment. So these four regions. So what happens today is when you say there's an issue in the production, right? The data, only the production data can help you test that. So you would say, okay, bring that table. Think that table is as big as it has millions of records. It has millions of records, right? So previously, when this zero copy architecture did not exist, what would you do? You would bring that data to dev. You will test your scenario where the process is failing in production, right? Even the QA. So QA team has to test your job, right? They also need the same data. You will copy to QA, right? And to prove that it works for the user acceptance testing, you will still move a copy to, so think the same copy of the data has been moved to multiple regions, right? And increasing storage. So what the zero copy architecture helps is it points the data. You don't have to make the multiple copy, but you will make a configuration that your development code is connected to the same location where the production data is. So you basically have only one copy, right? It's just a configuration or a setting change. And today the Snowflake database that supports this zero copy architecture. Okay. Optimized hardware. Transition to solid state drives, which are significantly more energy efficient than traditional spinning hardwares, and use all flash configurations for a greener power profile. Okay. So you also optimize your hardware. You don't think about your coding language. You don't think about the data that's being stored. You also optimize your hardware. You switch to the right storage device. So the storage is optimized basically. Okay. The access is optimized. Energy efficient data architecture. So what that talks about? Synthetic data generation, right? I said like using the AI, we don't have to use the real-time data. You don't have to use people's data. Rather than you can generate synthetic, like artificial, right? Rather than collecting energy intensive real world data, 75% of the businesses are expected to use Gen AI to create high fidelity synthetic data for training models, right? We said that machine learning uses the data based on the algorithm and creates a model, right? So if you are using fake data, right? You can generate it. Whatever command you will say, it will generate that data. So that would avoid the privacy risk. You don't have to give the information in case of customer, right? In case of the customer's data, which is very critical. It has PII data. All of our customer information is very critical. Our date of birth, our gender, our addresses, right? All those stuff. So if we give that data, real life data, to train the AI, that is breach. So that way you basically use synthetic data. You can use AI to training the models using this synthetic data, and carbon cost for the massive primary data collection. You don't have to do it. Can generate on the file, right? On the flow, right? The agentic edge. So moving AI processing to the edge, we covered that, right? Edge computing on the local, close to where the data is generated. Move the data processing to close to where the data is generated, the business exists. That reduces the massive energy expenditure required to transmit the data back to the centralized cloud centers. Do as much as processing in the local local data centers and only transmit what is needed, the result, the summary, to the centralized cloud centers for decision making. Okay, sustainable infrastructure and sourcing. Green cloud migration. Move the workloads to hyperscale cloud providers, right? Remember, we saw some cloud providers like AWS, Google, and Microsoft that use 100% renewable energy and achieve a high power usage effectiveness than most on-premise centers, right? Let's move to those cloud providers which are moving towards the green strategies. Circular hardware management. Instead of full hardware replacement, adopt modular systems where individual components like CPUs and RAMs are upgraded or repaired, and use certified IT assessment disposition to recycle or refurbish the decommissioned drives. Right? When we are replace only the parts, reduce the waste, right? You want to replace the CPU, only replace the parts instead of just throwing away the whole stuff. Oh, this doesn't work at all. Let's try to all think about in this way that we are reducing the waste, right, on the Mother Earth. Heat recovery. Heat recovery is like in 2026, many sustainable data centers redirect waste heat to nearby buildings for district heating or turning an environmental byproduct into a shared resource. So, what is this heat recovery, right? Capturing the waste heat generated by servers in data centers and reusing it instead of letting it escape the air. Examples are like in Sweden, the data centers send the waste heat to city district heat network, and the heat warms the thousands of apartments, reducing the need of fossil fuel heating during winters. Right? What a good example. What a good, great moment. The data center plus swimming pool. So the waste heat is redirected to a public swimming pool, which eliminates or reduces gas-based heating, right? So these are all the sustainable infrastructure and sourcing examples that people can utilize or move towards. Examples to learn from. The data minimization and lifecycle management. What is data minimization? I think it's almost resonates with what we have gone so far, right? Aggressive data audits. Data audit should be there. Data governance should be there. So there should be people, you just don't keep storing the data. There should be audits there. Actively identify, right? Actively identify and eliminate dark data, unused data, redundant or outdated data that occupies 50% of the global storage today, to directly reduce the energy used by the servers, right? If you have less data, you might instead of, so today you have 100 GB of data. For 100 GB of data, you need two servers, but maybe that data 100 GB, only 50% is, unique, 50% is valid, 50% is clean, the other 50% is duplicate, right, or unused. Archive them, tired archiving. Automatically move infrequently accessed cold data to low power cold storage or archival tiers rather than keeping it on a energy intensive active drives. So I gave an example, right? Why would you keep the customer information on your frequently accessed table, right? Who are no longer your customers, right? Who don't even log into your system. So we can use AI and monitoring to check, okay, when was the last time this user logged in, right? Or he doesn't have a current account. What are the chances that he will try to log in, right? So that is something, tired archiving, right? Tired archiving. Retention policies. Implement strict data retention policies that mandate the deletion of data once its legal or business value has expired. Okay, Amazon has thousands of products. Okay, some products are not sold anymore. They are old or the variations of the product has come. So you can remove those products from your main storage. You can archive it or maybe completely get rid of it. If that product is not complete produced, that you don't need it on your system, right? Prevent permanent storage growth. Always, always. So we in our company, we do have these data governance team, data audit teams that check what is happening, or there are admins who monitor the server, who checks the performance, right? What is happening behind the scenes, when during these data loads, are they seeing any performance issue? Is the query running in an optimized way? Or else they will come back, that then come back to the developer and check, okay, analyze your data, right? Why is your table growing like anything? It's not a manual, right? Automatic, like they have the bots ready to scan the tables, to scan the data and check the size. And if it's something not looking good, they will always reach out back to the IT team and asking us to check. Okay, I know we have few more minutes here. So then I would like to say that as educational institutions, we are the living labs, right? We can have smart campus, energy dashboards. We can support the solar rooftop integrations, which I see that Shantigiri College and several other colleges, I think most of the reputed institution do have the solar energy integration into the system, right? Yesterday, the first speaker from yesterday, she was talking about checking the rooms, right? Not, I mean, using AI, like what is the occupancy, what is the which rooms are being utilized for booking a meeting, for scheduling an extra class for the students, which rooms are being utilized, are the rooms available, can we utilize them in a better way, so that, or automatically switch off the power, like there should be some way. So we should be putting these thoughts into our students, right? When we talk to them, give them examples to reduce this wastage. We don't know, even if it's a small contribution, right? Tomorrow, that, like these many students, when they go out and work on different industries, they would imbibe these values. Real-time energy monitoring, right? Real-time energy monitoring, how much is being utilized, are we wasting, is it getting wasted, what is being produced versus what is getting wasted. We need the participation of both the students and faculty in these type of initiatives, I would say. The key takeaways from this presentation that I had is energy stability is critical for India's growth. Not India's growth, it's everybody, the whole world, right? And smart data enables reliable renewables. So if you have the live data monitoring, if you have the demand and supply monitoring, you are monitoring how much renewable energy is available to you. You can predict it based on the weather and other stuff. Then you can always enable the reliable renewable energy usage. Digital tools improve climate resilience, right? And I would say that faculty plays a leadership role here. You are training tomorrow's future, right? And based on what we teach, these people are going to become tomorrow's IT leads, or they can be prime minister, they can be policy makers, they can be anyone. So if all of them have this good thought and move towards the green initiative, the world would be a better place. I would say my closing thought is that the future of energy is not just green, it is intelligent. With that, I would like to open up for questions. Any questions?
Thank you, ma'am, for the enlightening session. Now, the participants are requested to post their questions in your chat box. Thank you once again for your active participation. Now, I request all the participants to kindly fill out the feedback form. All the feedback links are open and it will be shared in the chat box. To formally conclude today's program, now I invite Mr. Jibin George, HOD, Department of Computer Science, to deliver the vote of thanks.
Respected Ms. Rishmi, on behalf of Conference Organizing Committee, I sincerely thank you for delivering an insightful and engaging talk on energy stability through smart data management. Your expertise and clear presentation greatly enriched this conference and provided valuable perspectives to all participants. So we truly appreciate your time, effort, and contribution. Thank you.
Thank you so much.
We conclude day 2.
No, I'm good. I was just saying thank you so much for the patience and to the staff of Shantigiri College and all the patient listeners. Hope I was able to trigger a thought about the green initiative, which we will take further.
Excuse me, Rashmi ma'am. Excuse me, ma'am.
Yeah, go ahead.
There's a question from the participant side.
Let me see the chat.
How far can we implement data minimization and life cycle management in colleges?
Okay. How far can we implement data minimization and life cycle management in colleges? So the different departments, right? You have, I'm sure every college would have a student information system. So we have to make sure that we have one copy, one source of truth. I like individual teachers, like individual departments. When it comes to computer science department, the same student might be taking a course in a different different subject area. So that is something that we can data minimization. We teach our students that okay, when you write a code, when you copy the data right from one place to another, you don't make multiple copies or clean up. Don't leave it there before the end of the semester, right? They can do that. And if I'm not sure if it was related to the student information system, but these are the some things that we can do, right?
Okay, ma'am. Thank you.
Thank you. Thank you all.
As we conclude day 2, we sincerely thank all the resource persons, participants, organizing committee members, and the technical team for making today's session meaningful and successful. We look forward to your continued participation in the upcoming sections of this FDP. Once again, I remind you that all the feedback links are open and it will be shared in the chat box quickly. Thank you all. Have a pleasant evening.
Thank you. Have a good night.